Today's class is about indices. And just to make it a bit clear, in singular, it is called index. Therefore, indices is plural of index. Just to begin with, I'll say an index, or also known as a power. An index or a power is a small floating number that appears after a number or a letter. That is theory. In terms of mathematics, I'll give an example here and say, if I have my a power 3, for example, let me begin with a power 1. We all know that a power 1 is equivalent to a. That's a is a number multiplying by itself, so it's a once, so that is a. A squared, or rather a to power 2, becomes a times a. A to power 3 is the same as a times a times a. And a to power 4 comes to a times a times a times a, and so on. This number, a to power 1, a to power 2, a to power 3, and a to power 4, this a here, this a, letter a here is the base, and this one is what we are calling the index, or the power. The same to this a, the base a, this is the base, and this 2, that 2 is the index, or the power. When it comes to a power 4, this a is the base, and that 4 is the index. So in other words, I can say 1, 2, 3, and 4, those numbers, number 1, 2, 3, and 4 that I've used here, are called the indices. So this chapter will deal with this, what I have defined here. I've been able to define what a base is and what an index is. So when index comes together, many indexes are known as indices. So this chapter will deal with this. So the first thing I'll look at, after defining what a base is and what an index is, I want to look at the laws of indices. Laws of indices. Law number 1, we have the multiplying law, that is multiplying indices, which says, if I have, for example, let me use letter m power a times m power b, then this law says that if the bases are the same, this is m and m, base m, so the law applies only if we have the same base. So far I know the student understands what the base is. The base is this m. If you can check on the definition, then you pick on one of the base, and if this is multiplication, then you add the power or the indices. So that is what the law says that if we have the base being same, then you add the power. Just to give examples, an example here. If I have, for example, 2 power 2 times 2 power 1, then what I have said is these bases are the same base, that is base 2, same base here, the base is 2, the base is 2, pick on one of the base, and if this is multiplication, then you add the powers, that is 2 plus 1. So the answer will be 2 power 3. 2 plus 1 becomes 2. 3. Another example, that is example 1. Let's look at example 2. Example 2. If I have k power 6 times k power 2, for example, then the base is the same, that is k. You pick on one of the base and you add on the power. You add the powers. Why are we adding the powers? Because it is multiplication sign. So the answer becomes k 6 plus 2, that is 8. K power 8. Another example here. Example 3. If I have, for example, 4x, x2, y3 times 2x, y. What will be the answer if we use the law of indices? This is multiplication, so we will deal with numbers first, separately. 4 times 2, that is 8. Then we come to x power 2. What is the sign? Multiplication sign, times x. Kindly remember, x is x power 1. Is the base same? Yes, so that is x. 2 plus 1, the answer is x to base 3. X to base 3. The answer is x. Sorry, not x to base 3, but x power 3. Last value, letter to deal with is y power 3 times y. Kindly remember that if it is y, then we are simply saying that is y to power 1. So this becomes y times, the base is the same, so pick on one of the base. So that becomes y 3 plus 1. Why are we adding? It's because the bases are the same. So we are adding because this is a multiplication sign. So this is y to power 4. So finally the answer becomes, our answer becomes 8. This one here. X power 3. And y power 4. That is the law of indices, the multiplying law of indices. The multiplying law of indices. So law number 2, we have the division law of indices. The division law of indices, that is dividing indices. This law says if I have my m here to power a, you divide by m to power b. The bases are the same. The laws only apply when the bases are same base. My base is m and m, so I will have my m, then a minus b. Why minus? Because this is division. This is division. Let's look at an example here. Example 1. If I have letter, for example, 3 power 3, you divide by 3 power 1. Are the bases the same? Yes, so this becomes 3 minus 1. So the answer finally is 3 to power 2. That is the answer. That is the answer, example 2. Example 2. If I have, for example, 2x power 7, you divide by 2x power 3. Okay, we begin with the numbers separately. You divide this 2 divided by 2, 2 divided by 2, we know that the answer is 1. Next, x power 7, you divide by x power 3. The bases are the same, that is x. 7 minus 3. Why are we subtracting? Because the law of division says if the bases are the same, then you subtract the power. So the answer here is x to power 4 to this. So finally, our final answer for this, the answer for this will be 1 times what? X power 4, which is the same as x to power 4. X to power 4. That is x to power 4. Example 3. Example 3. If I have something of this sort, I have 4 x, y, let's say this is x 3 and y is 1. Then we divide by 2 x, y. Let's deal with this separately. We begin with these numbers. 4 divided by 2, the answer is 2. X power 3, you divide by what? X. And this x simply means this is to power 1. The law of division says if the bases are the same, which is true, the bases are the same, that is base x to base x, then we subtract the powers on the index. So the answer becomes x to power 2 for that case. I have my y power 1. I divide by what? Y power y. That means also y power 1. So the answer here will be the bases are the same. What do I do to the power? I subtract y. That is 1 minus 1, that is y power 0. I'll go ahead in my later class, I'll tell you that y power 0, any number raised to power 0, the answer is 1. So finally, the answer to this question becomes 2, this is 2, x squared times 1, which is simply the number. So the answer here is 2x squared. 2x squared, the laws of indices. The laws of indices, that is the division law of indices. Let's look at law number 3. Law number 3. The law number 3 for indices. The third law of indices. The third law is raising a power to a power. Raising a power to a power. That is the third law of indices. What do I mean? If I have my m raised to power a, then I multiply it, I raise it again to power b. That is what you are saying. You raise a power to another power. So the answer finally becomes, according to the laws of indices, this will be MAB. It will be MAB. AB. MAB. That means if I have 3 to power 2 raised to another power, which is 2, then the answer becomes 3. This times this becomes 4. That's just an example. Example 1. Example 2. If I have x power y raised to 2, then what is the answer? The answer is x to y. X to power 2y. If I have another example here, example 3. Example 3. If I have, for example, 4x power 2, 4x power 2. If I have, for example, 4x power 2 raised to power 2, then you raise what is in the brackets to the power of 2 separately. So that will be 4 power 2 times x 4. 2 times 2, and also this will be 2. So finally the answer will be 4 power 2, that is 16 x power 4. X power 4 model. Raising a power to a power. Raising a power to a power. Lastly, the other law of indices says that if we have this law number 4, any number or letter raised to power 0 or index 0, the answer is 1. Any letter or any number raised to power 0, the answer is 1. So that means k power 0, what is the answer? 1. 10, 20 power 0, the answer is 1. W power 0, it is 1. 1 to power 0, the answer is what? 1. Any number, if you raise it to power 0, then the answer becomes 1. Look at this example. For example, I have an example here. X, y power 0. What is the answer? The answer will be x times 1, which is x. Y, it is not x raised to power 0, it is y raised to power 0. So y power 0, it is 1. 1 times x, it is x. Look at this as another example. X power y times x y power raised to power 0. Raised to 0, rather power 0. What will be the answer? This means everything in brackets raised to power 0. So the answer here is 1. I hope the student is able to know the difference between this and this. It's only y that is raised to power 0. For this case, it is the 2. That is, what is inside the brackets is raised to power 0. So according to this law of indices, the answer is 1. The answer is 1. Another example based on that law. Another example. If I have 2xy power 0, what will be the answer? The solution to this will be 2. 2 is not raised to power 0, neither x. What is raised to power 0 is y. And any number raised to power 0 is 1. So 2x times 1, the answer is 2x. That is a law of indices. What I want to do next, after having known these laws, we need to solve a few questions that will make us understand the topic further. For example, you are told to evaluate. So let's talk about further examples. We are told here to evaluate 9 power a half, or raised power half. The first thing to do is find the factors of 9. Use factor method and find the factors of 9. That is 9. 3 goes here, 3. So 9, the factors of 9 are 3 to power 2. So after finding that your 9 is the same as 3 power 2, that is 9, it has been raised to power a half. If you have been so keen, this is law number 4 that I have taught. Power raised to power. What did we say? I said when a power is raised to a power, we simply multiply. So the answer here will be 2 times a half. Cancel this, this is 1. So finally we'll have 3 raised to power 1, which is 3. Law number 4 has been used. They are also saying evaluate 10 power 0. Oh yes, we know that any number raised to power 0, the answer is 1. 1, just as simple as that. They also want us to evaluate 125 raised to power a third. What do? We find the factors of 125. So the factors 125, can 3 divide? No, just 5. 5 goes here 2 times 10, 25, 5, 5, 5. So that is 5 to power 3. So 125, the factors are 5 to power 3, 5, 5, 5. So this is 5 power 3. Raised to what power? To power a third. I think that law number 4 has been applied. So what do? We say this is 5 power 3 times a third. 3 and 3 will cancel, remain with 5 power 1, which the answer is 5. The answer is 5. Laws of indices. We are just, I'm giving more solutions just to enhance the understanding of the laws. Enhance the understanding of the laws. Let's look at this one. We are told to evaluate 16, 3 over 2, 3 over 2. Find the factors of 16. Factors of 16, that is 16, 2, 8, 2 divided by 8 divided by 2, 4, 2, then 2. So 16 is equal to 1, 2, 3, 4. 2 times 2 times 2 times 2, 1, 2, 3, 4, which is the same as 2 power 4. So 16 is 2 power 4. Raised to which, or to what power? 3 over 2. Law number 4 still being emphasized. So that is 2, 4 times 3 over 2. 2, 1, 2, 2. 2 times 3, 6. So that is 2 power 6. 2 power 6 is the same as what? 2 times 2 times 2 times 2 times 2. 1, 2, 3, 4, 5, 6. This is 4, 8, 16, 32, 64. Or if you are told to leave your answer in the form of mn, then the answer becomes 2 power 6. That is, if you are told to leave your answer in index form, then it becomes 2 power 6. 2 power 6. We are being told further examples. We are being told here we are told, student has been told to evaluate this. I'm just emphasizing on the laws of indices. The laws of indices. You have been told, example, evaluate 2 power x is equivalent to 32. 2 power x is equivalent to 32. What to do is you find the factors of 32 with respect to 2, because we want to make the bases the same. So the first thing to do here, make the bases same. That is always the first thing to do. So we have our 2 power x is equals to 32. So this is lowest already, we can't make it to any other base other than 2. So we'll find the factors of 32, 2, 16, 2, 8, 2, 4, 2, 2, 1, 2, 3, 4, 5. So 32 is equivalent to 2 power 5. So you bring it here and say this is 2 power x is equals to 2 power 5. Are bases the same? Yes, same base. Same base. So if the bases are the same, number 2, this was number 1, make the bases the same. Number 2, equate the indices or the power. Equate them. What is the power to 2? It is x. What is the power to this other 2? It is 5. So what is x? X is equivalent to 5. X is equivalent to 5. X is equivalent to 5. Solve for x. Another example. Solve for x. And you are given here 3x plus 2 is equivalent to 81. Is equivalent to 81. This is base 3, this is base 81. So what was the first thing I said you should do? Make bases same. This is to the lowest number, so we make 81. We find the factors of 81 with respect to base 3. So 3, 27, 3, 9, 3, 3. 1, 2, 3, 4. So 81 is equivalent to 3 power 4. So we bring it there. After that, so we'll say this is 3x plus 2 is equals to 3 power 4. Number 2, what did I say? I said equate the indices only if the bases are same. Kindly note this. You only equate the indices if the bases are the same. So 3x plus 2, what is the index there? X plus 2. What is the index on the other side? Is equals to 4. Mathematically, just take 2 to the other side, so we'll have x is equals to 4 minus 2. X is equivalent to 2. We have solved for the value of x. We have solved for the value of x. So we are just, I'm giving more examples to enhance your understanding on this particular topic. Solve for x in 3x minus 2 is equals to 16. Bases are not same, so number 1, make the bases same. So find for the factors of 16 with respect to 2. This is 8, 2, 4, then 2 to 1, 2, 3, 4. So 16 is equals to 2 power 4. So we have 3x minus 2 is equivalent to 2 power 4. Are bases the same? Yes, same bases. Same bases. So number 2, what do? We equate the indices. We equate the indices. So we have 3x minus 2 is equals to 2 power 4. So just equate the indices. That is 3x minus 2 is equals to 4. 3x is equals to 4 plus 2. 4 plus 2. 3x is equals to 6. Mathematically, we divide this by 3 by 3. So our value for x is 2.